Hello grade 9s, welcome back to my channel, or welcome if you're new. I'm Miss Martins. I do maths videos, I do physics and chemistry videos, so please hit the subscribe button, become one of my YouTube students if you haven't already. In today's video, we're going to be doing an exam past paper question based off of algebra. We'll be covering the three big parts of algebra that you need to know: simplifying, which you can see behind me, factorizing, and solving for x. You approach each of these things very differently, and I'm going to go through each of these questions, and while I'm going through them, I'll give you some teacher tips along the way. Let's get right into simplifying. 2.2. Right, let's tackle each one of these questions, starting with 2.1.1. So in 2.1.1, you can see that there are two parts to this expression. We've got the cube root of x to the power of 3, or x cubed, plus x to the power of 0. Now, this is testing your knowledge based on exponents. Now, this is a very good one, actually. I like this one. If you have something that is under a root like this, so if you have roots, let's just do x to the power of 8. How we simplify this is we take the exponent, which is 8, and we divide it by whatever number is over here. Now, when it comes to a square root, like this made-up example over here, the little number over here is an invisible 2. So we go 8 divided by 2, which is 4, x to the power of 4. So it's this number divided by this number. So in the case of this exam question that is on the screen over here, it's this number divided by this number. Now, what is 3 divided by 3? Yes, 3 divided by 3 is 1, so we've got x to the power of 1. And no, you don't need to write to the power of 1 there, you can just say x. Plus x to the power of 0. Now, this is something that you just need to know. Anything to the power of 0 is equal to 1. So if you take your calculator, and you can do this at home, if you type in 5 to the power of 0, you're going to get 1. If you type in 1 million to the power of 0, you're going to get 1. So essentially, my answer there is 1. And x plus 1 is just x plus 1. We can't add those. They're not like terms. My next question, 2.1.2, has a big square root, and we have something going on underneath the square root. Now, when you see a square root, I always want you to check underneath the square root and see if you can simplify underneath the square root. Think of the square root as being like brackets. If I have brackets, we always look inside the brackets first to see if we can simplify. It's called BODMAS. So in this case, look underneath the square root and see if you can simplify. Underneath the square root, I have two terms, 0,03 x to the power of 8 and 0,01 x to the power of 8. Can I simplify those? Yes, I can. Can I add these two together? Yes, I can. How do I know I can add them together? Because they're like terms. Now, this often confuses a lot of my grade 8s and my grade 9s. They'll say, ma'am, but this number, 0,03, is different to 0,01. Why are they like terms? When I ask are they like terms, I'm asking you to compare the variables and the exponents. If they have the same variables, so if they're both x and x, and it has the same exponents, x to the power of 8, x to the power of 8, then they are like terms. So for example, if I have x to the power of 8 plus x to the power of 8, can I add those? Yes, you can. Your answer is 2 x to the power of 8. You have one of them plus one of them, you have two of them. When you add like terms, you're adding these big numbers in front. If I have x to the power of 8 plus x to the power, why am I writing that? X to the power of 8 plus x to the power of 6. Can I add those two together? No, they're not like terms. Remember, they must have the same variables, so they must both be x's, which they are, but they must also have the same exponent. So 8, and that's not 8, so you can't add them. So your sum would stay like that. X to the power of 8 plus x to the power of 6. And please, I know I might be going off on a tangent now, unrelated, but a lot of my students say, but ma'am, why can't I add these together? No, that is only when I am multiplying. So if I say x to the power of 8 times x to the power of 6, then are the bases the same? Yes, I keep the base and I add the powers. That is when I say 8 plus 6, which is 14. So when I multiply and the bases are the same, I add the exponents. If I'm adding, so if I'm plusing or minusing like here, then it's like terms. then they need to have the same base and the same exponent. Okay, so back to our sum. I can add these two terms over here because they have the same base, x, and the same exponent, 8. So how do I add them? What is 0,03 plus 0,01? I hope you're telling me it is 0,04 x to the power of 8. Okay, so you just add the big numbers together, and the powers, you don't touch the powers, you don't touch the exponents. Now I'm not done. What I've done so far is I've simplified underneath the square root. Now I actually have to apply the square root. So here's where you can take your calculator and you can type in the square root of 0,04, and we don't even need our calculator to do this, but it is 0,2, okay? 0,2. The reason why you should know that anyways is because 0,2 times 0,2 gives you 0,04. Okay, so the square root of 0,04 is 0,2. And remember the rule I just taught you. When you have a variable with an exponent, you divide that 8. What do I divide that 8 by? Yes, you divide that 8 by this number over here, which is an invisible or an imaginary 2. So it's going to be x to the power of, what is 8 divided by 2? 4. That is your answer. So where do you get your marks in this question? You get 1 for first simplifying and 1 for applying the square root. Some question papers might give you 3 marks. They might give you 1 for that one, 1 for this one, and 1 for simplifying over here. 2.2.2 is quite challenging. We have to apply the rule that I call the power inside times the power outside rule. Now, what I mean by this rule is if you have something in a bracket like this, like x to the power of 3, and that is raised to another exponent, let's say 2. You take that exponent or that power and you multiply it by that one. So what is 3 times 2? It is 6, x to the power of 6. And this rule applies even if I have numbers inside brackets. So say I have 2, x to the power of 4, and that exponent is 3. This number over here has an exponent of 1. So it is 2 to the power of, what's 1 times 3? 3. And this 4 times 3. So x to the power of 12, and then 2 to the power of 3 can be written as 8. I hope that makes sense. So you apply the power inside times power outside rule to everything inside the bracket. So if I make this a little bit bigger, maybe that'll help us. The 2 has an exponent of 1, like that. The d has an exponent of 2. The e has an exponent of 1. Okay, let's deal with the top first. We'll come back to the bottom now. So it's 2 to the power of 2. Where did I get that from? Because it's 1 times 2. D to the power of 4, because it is 2 times 2. It is e to the power of 2, because it's 1 times 2. So instead of writing 2 to the power of 2, what is 2 to the power of 2 equal to? It's equal to 4. So I can write it as 4 instead. Okay, now I do the same thing, but I do it for the bottom. 4 has an exponent of 1. D is an exponent of -3. E has an exponent of -2. So we're going to go 4 at the bottom. What is 1 times -1? That's -1. D, -3 times -1 is +3. Remember, negative times a negative is a positive. E, -2 times -1 is +2. Okay, now, the next thing that you need to know is we do not like negative exponents. So do you see how this 4 has a positive exponent? It's invisible, but it's 4 to the power of 1. This D has a positive exponent. It's +4. This E is a positive exponent. This E is a positive exponent. That one has a positive exponent, but this exponent is negative. We do not like negative, so this is how I teach it to my grade 9s. The one that has a negative exponent, let's circle it. That one needs to move. So if it's downstairs, so if it's in the denominator, it must move upstairs. If it moves upstairs, the exponent becomes positive. So what was originally upstairs? 4d4e2. Then 4 to the power of -1 comes upstairs. It gets 4 to the power of +1. So that's just moved. What's left over at the bottom is d to the power of 3, e to the power of 2. Okay, I'm still not done. How do you know that you're still not done? Because a lot of my students get to this point and they think they're done. They're like, yeah, I'm done, ma'am. How do you know that you're not done? You know that you're not done because you have D's, you have a D at the top, a D at the bottom. You're not done. If you have an E at the top, E at the bottom, you're not done. You only want one D in your answer, one E in your answer, and one big number in my answer. So what you'll do now for me is we take the big numbers. You see that they're both at the top of the fraction. So it's 4 times 4. What is 4 times 4? 16. Then we've got one D at the top, another D at the bottom, which means basically I'm saying D to the power of 4 divided by D to the power of 3. When you divide, if the bases are the same, which they are, we minus the exponents. So what is 4 minus 3? It's D to the power of 1. The E squares cancel. That's my final answer. 2.2.4, again, this is a simplify question. This would be very different. We would approach it very differently if the question said factorize, but it says simplify. So if you see simplify and you see brackets like this and numbers outside the brackets, I need you to think of the following words: expand, distribute, multiply in. Some people call it FOIL. So basically it's the basic rule. Let's take a sum like this, 3x plus 4. What do you do if you see something like that? You must multiply the 3 into the brackets. Multiply. So it's 3 times x is 3x, 3 times 4 is 12. So basically, when you see simplify, you see brackets, you see that stuff, you need to distribute, you need to expand, you need to multiply in. Another thing that I also tell my learners is that if you see a bracket like this, and the bracket has 2 terms in it or more, and you see a squared like that, so if I have like x plus 4 squared, what I want you to do is I want you to write the bracket out twice. X plus 4, and then we do our distributing or our multiplying. So in this question, what I see is the following. I see x plus 2 squared. That means that I need to write out the bracket twice. So I've got x plus 2, and then I'm just going to write the rest of the sum as normal. So I haven't actually done anything really in the first step. All that I've done is, because it says x plus 2 squared. Squared means twice. You see the number 2? 2. I write the bracket out twice. Now what I'm going to do is, if you see two brackets next to each other like this, I want you to apply the method that a lot of textbooks, a lot of teachers call the FOIL method. Okay? How the FOIL method works is as follows. You multiply the first term by the first term. You multiply the outer term, so x times 2. You multiply the inner terms, 2 times x. And you multiply the last terms, 2 times 2. Another way to think of it is like this. The x, this one in the first term in the first bracket, needs to be multiplied by both terms in the second bracket. The plus 2 in the first bracket needs to be multiplied by both terms in the second bracket. So we're going to do FOIL over here because there's two brackets next to each other. We're also going to do it here. That times that. And then we've got x times 2 like that. That's the outers. We do 1 times x and then 1 times 2. So what I want you to do first is carry down this 2. We're not multiplying it in yet. We're first going to do the method called FOIL. Then you open a bracket, and my answer to FOIL is going to go in that bracket. So let's do it again together. What is x times x? X squared. When you multiply and the bases are the same, you add exponents. So we did x times x, so we did that blue arrow. That blue arrow is the red arrow. The red arrow is done. Then we're going to go x times 2. That's 2x. The blue arrow is now done. Then we're going to do the green one. What is 2 times x? 2x. Green arrow is now done. And then we're going to do the purple arrow. What is 2 times 2? 4. Close bracket. So see how I've carried the 2 down. I've done FOIL. Now I'm going to do the same for the next half. Carry the negative 2 down. Now let's do FOIL again. Open up your leftover brackets. Well, not really your leftover brackets, basically your answer brackets. X times x, x squared. X times 2, 2x. 1 times x is x. 1 times 2 is 2. Close bracket. Now what you're going to do is the stuff that you originally carried down, that number, so this one over here, that now needs to be multiplied into this bracket. And what we can actually do first is we could simplify inside the bracket, but I'm first going to multiply. So 2 times x squared, 2x squared. 2 times 2x, 4x. 2 times 2x, 4x. 2 times plus 4 plus 8. So I hope you notice what I did there. Basically the number outside the bracket, so in this case it's a 2, needs to get multiplied by every single term inside the bracket. Same thing with the next one. The negative 2 outside the bracket needs to get multiplied by every single little term inside the bracket that it's outside of. So negative 2 times x squared, negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times x, negative 2x. Negative 2 times 2, negative 4. Now what we can do is we can get like terms together. So remember, as I said earlier in the video, like terms are when they have the same variable and same exponent. So in this case, 2x squared is the same as negative 2x squared. Why are they the same? Because x squared and x squared. Then these are the same, 4x, 4x, negative 4x, and negative 2x. And then last but not least, the ones without variables, 8 and minus 4, those are the same. So we're going to put those together. What is 2x squared minus 2x squared? So I had 2 of them. I'm minusing 2 of them. I now have 0 x squared. So leave it out. Then I've got 4x plus 4x, which is 8x, minus 4x, takes us back to 4x, minus 2x, which is 2x, and then I've got 8 minus 4, which is positive 4. There we go. I know it is a lot of work, but hopefully you don't find it difficult. You need to go through each step slowly to avoid making sign mistakes. My next question says factorize completely. When you see the words factorize, you need to think of the different types of factorizing, namely highest common factor, which is the most important type of factorizing. We then also have something called common bracket, which is technically part of highest common factor. I like to group these two together. We also have dots or difference of two squares, and we have trinomial. That is, or those are my different types of factorizing. So when the question says factorizing, I don't want you to think of adding like terms. I don't want you to think of multiplying or distributing. I want you to think of those types. So I do have videos on those types if you want to check them out on my channel. Highest common factor, that's where we look at each of the terms. How many terms do I have? I have 1, 2, 3. You look at each of those terms and ask ourselves if I can divide each of those terms by the same thing, or if there's a number or variable that each of these that can divide into each of these. So can I take anything out of each of them? You might say x, but this term is x, this term is x, this one does not. So we can't take out an x. You can't take out a number either because there isn't a number that can divide into 5 and 24 without a remainder. Okay, so it's not HCF. It's not common brackets. I can't take out a bracket anywhere. It's not dots. Dots is difference of 2 squares. For dots, we would need 2 terms. But I don't have 2 terms. I have 3 terms. So therefore, it is trinomial. Let's do a trinomial. 2.3.2 again says factorize completely, but I know a lot of my grade 9s make the mistake even when they see the word factorize and they see this sum, they think that they must distribute or multiply in. So they want to say 2 times a and 2 times negative b. They want to do the distributive law. No, the question does not say simplify. It also does not say expand. It doesn't say distribute. It doesn't say multiply in. It says factorize. So when you see factorize, you need to think of the following types of factorizing. Like I said, start with HCF. Try it first. If it doesn't work, try common bracket. If that doesn't work, try difference of two squares and then try trinomial. Now, this one might not be obvious, but this one is actually a common bracket type of factorizing. And remember, your teacher might not have called it common brackets. It's technically part of HCF. Now, before we do this specific common bracket sum, I want to just remind you of a very basic common bracket example. If I give you the following question and it says factorize, again, we're not going to say 3a multiplied by x and 3a multiplied by y, because that's not factorizing, that is simplifying, that's distributing, that's expanding. So again, when you think of factorizing, we're going to think highest common factor or common brackets. In this case, we're going to do common brackets. Now, how many terms do you see on the screen? I hope you're saying 2 terms, because 2 terms is the correct answer. That's 1 term. And that's another term. Remember, terms are separated by plus and minuses, so the minus separates the term. Because this is in brackets, this is all part of the first term. Okay, so we see 2 terms. Now ask yourself, what do the terms have in common? What can I take out as a highest common factor? Technically, it's a highest common factor. I call it common bracket because, yep, in this case, the bracket isn't common. So this term has x plus y. This term has x plus y. We take out the highest common factor. So x plus y comes out. What's left over from the first term? So if you take the first term and divide it by x plus y. So in other words, we're taking x plus y away. That's gone away. What's left? 3a. Okay, so 3a is left over from the first term. If we do the same with the second term, take x plus y away, what are you left with? Negative b, like that. And that is how we would factorize that expression. Now, the question that was given to us in this exam paper is similar, but you might be thinking, but ma'am, I don't see 2 brackets. I just see 1 bracket. Yes, that is true. My bracket over here has a minus b. But if you look over here, we almost have something that is a minus b. It's just written the other way around. So what I'm going to do is I'm going to rewrite this to a minus b. And over here, I'm simply just going to swap the order of these 2 terms. So I'm going to write the positive a first, and then I'm going to write the negative b. Do you see that I haven't done anything? I haven't changed anything. I haven't changed the sum. I took the negative b and the positive a and I swapped their places. I just moved them. So it's basically like saying, instead of saying 3 plus 2, I'm saying 2 plus 3. It's the same thing. I haven't changed the sum. Okay, cool. Now what I'm going to do is I'm going to put brackets around this one here. Now how many terms do I have? Ignore the original sum. There's 1 term. And there's the second term. What do those 2 terms have in common? Yes, the bracket. You take the bracket out. A minus b. If you divide the yellow term by a minus b. Okay, we're taking it out. We're dividing the yellow term by a minus b. What is left over? 2. 2 is left over. So open your leftover bracket. We've got a 2. Then we do the same thing, but we're going to do it for my second term. Okay, so what do I do here? What is my second term? If I take my second term, which is this one, a minus b, and I divide it by a minus b, what's left over? They cancel. So what's left over? Positive 1. Anything divided by itself is 1. And then we can simplify that, a minus b, 3. And yes, it might make more sense to write the 3 first. And that's it. That is my question fully simplified, factorized and simplified towards the end. I know this one is a little bit more difficult, but you need to know how to do this in order to do well in your exam. Right, moving on to solving for x. Now remember, when we solve for x, we want to do inverse operations, so we want to get x by itself. Ultimately, we want an answer that says x is equal to, like that. We need to do inverse operations. So, for example, if we take a look at the first sum, 4x minus 10 equals 6. We want to get x by itself. We need to get rid of everything else that is with the x. We need to do inverse operations. So this is minus 10, or subtract 10. What's the opposite of minusing? What's the inverse of minusing? Plussing. So we're basically adding 10 to both sides. That gets rid of the 10 on the left-hand side, so we're left with 4x, and we've added that 10 to the right-hand side. Okay. Now, this is a step that you don't need to show. Now, this is times 4. What's opposite of times 4? Divide by 4. What is 16? Divide by 4? 4. You do not have to show the middle steps. You'll get your marks like that. 2.4.2 is what I like to call equations with fractions. And when you have equations with fractions, you need to follow the following steps. First off, write everything as a fraction. So here's a fraction, here's a fraction. That step is already done for us. However, in some sums, they might say, for example, they might add like a plus 5 over here. Then you would just have to write it over 1. So we need to write everything as a fraction. Okay, but in this case, that's done for us. Then write over the LCD. So LCD stands for lowest common denominator. We need to look at the denominators 2 and 3, and we need to find the LCD. So this is the lowest number, or the smallest number, that 2 and 3 can divide into without a remainder. So what can 2 go into and 3 can go into without a remainder? I hope you're saying 6. So what you're going to do is both fractions, you're going to write over 6. You need to ask yourself, what must I do to 2? So let's start on the left-hand side. What must I multiply 2 by to get 6? I hope you're saying 3. What you do to the bottom, you need to do to the top. Now, this is very important. You're multiplying this entire thing by 3. So we're going to go like this. 3 multiplied by 3x minus 10. Not only are you multiplying 3x by 3, you're also multiplying negative 10 by 3. Keep that in mind. Then we do the same thing, but on the right-hand side. What do you not need to multiply 3 by to get to 6? Times 2. What you do to the bottom, you need to do to the top. So you're multiplying that entire bracket by 2, like that. Okay, so write over LCD is step 2. What you do to the bottom, you do to the top. Put things in brackets if you need to, so if there's more than one term. Then, once they're over the same LCD, we can drop the LCD. So basically what we're left with is this. Like that. Then my last step is to solve like normal. So we're going to distribute the 3 into this bracket. 3 times 3x is 9x. 3 times negative 10 is negative 30. Remember, when you're distributing, you are multiplying. Very, very important. 2 times 2x is 4x. 2 times negative 5, negative 10. Okay, so we distributed. Now we need to solve like normal. You need to get the x's to one side. So I'm going to get the x's to the left. 9x is already on the left, so leave it there, 9x. 4x is on the right. It needs to come over. This is a simplified way of thinking about it. Basically, this has plus in front of it, invisible plus. When we take it over, it's going to become minus 4x. Essentially, what we're doing is we're getting rid of the 4x by doing inverse operations. We're minusing 4x on both sides. That's why it says minus 4x over here, and these 4x's cancel. Okay, but just to simplify it, I just say it goes over the equal sign. The negative 10 stays on the right-hand side, so it stays negative 10. The negative 30 comes over, and it becomes positive 30. So what we're left with is 9x minus 4x, which is 5x. 30 minus 10, or minus 10 plus 30, which is 20. So I'm just going to write over here because I'm running out of space. 5x equals 20. This is times 5. To get rid of the 5, because remember we want to get x by itself, we need to do inverse operations, which is divide by 5. What's 20 divided by 5? 4. That's your answer. 2.4.3 can be very simple, and you can get full marks if you know how to do it properly. So we've got x squared equals 4. Now, first of all, as soon as you see x squared, we know that this means that we're going to have two solutions. X equals something or x equals something. Two solutions. Now, in this case, x squared equals 4. When we're solving, we need to do inverse operations. This is an easy way to do it, a quick way that you learned in grade 8. What is the opposite of squaring? So squaring to the power of 2. The opposite of squaring is square root. Just by the way, opposite of cube is cube root. The opposite of to the power of 4 is fourth root. Yes, that's a thing. Okay, so what I can do is I can square root both sides. And just so you know, if you square root a square, those cancel each other out, so you just get x. And if you square root 4, you should get plus minus 2. Now, I know you're thinking, plus minus? Ma'am, why are you saying plus minus? A lot of my students will just answer by saying 2, because they type it in the calculator and it says 2. Your answer must be plus minus. It has to be two options. X equals 2 or x equals minus 2. Or you can just write plus minus 2. The reason why is because, remember, my sum said this. If I put 2 in the place of x, what is 2 squared? It gets me 4. That's correct. So x can be 2. But if I put negative 2 in the place of x, what's negative 2 squared? What is negative 2 times negative 2? Yup, positive 4. So x can be positive or negative. There's another way to do this. And this is a good way. You need to know this in grade 9 when doing quadratic equations. So if you see x squared, your steps can be make the equation equal to 0. So what I mean is this 4 can come over this side. It can be x squared. This was plus 4. There's an invisible plus in front of it. When it comes over, it's going to be minus 4. Now there's nothing on the right-hand side, so it's 0. Okay, so make the equation equal to 0. And then step 2 is factorize. So remember, when you see the words factorize, you need to think. Either we're going to do highest common factor, or common bracket, or difference of two squares, or trinomial. In the case of factorizing over here, we cannot take out a highest common factor. There's nothing that can be taken out of the first term and the second term. It's definitely not common bracket. This is what we call difference of two squares. I have two terms. There's a minus in between. This is how you know that you must do difference of two squares. Two terms, minus in between, because D means difference. Difference means minus. Minus in between. Square numbers and even exponents. And how we do dots is two brackets, plus in the one, minus in the other. What is the square root of this? X. What is the square root of 4? 2 and 2. And then I hope you can recall this from class. What you now need to do is we have two brackets and they're both equal to 0. What we need to do is we need to take each bracket. So x plus 2 is the one bracket, x minus 2 is the other bracket. Take each bracket and make it equal to 0. And put an or in between. Now what we do is we solve each equation. Take the plus 2 over, it becomes x is equal to minus 2. Take the minus 2 over, it becomes x is equal to plus 2. So can you see two solutions? X can be positive 2 or x can be negative 2. And just by the way, following those steps, so making it equal to 0, factorizing, making each bracket then equal to 0, that's the only way that you can, for example, solve this equation. So in the exam question that I just did, this one that I just did, there were two methods that you could have used. This I like to call the grade 8 method. We taught it to you in grade 8. And this is the more difficult method, the grade 9 method. But in the case of, say, this sum, the grade 9 method is the only way you can solve it. So what you would have to do is you'd have to factorize this by doing a trinomial, I hope you can see, like that. And then you would have to take each bracket and make it equal to 0, like that. And you would have to solve each little equation to get your two solutions. 2.4.4, last question, we're solving for x. This is x to the power of 5. But first things first, there's a 3 over here that I need to get rid of. So what you're going to do is, this is times 3. We're going to do the opposite of times 3, which is divide by 3. 96 divided by 3, and I hope you can do that. It's 96 divided by 3, it's 32, x to the power of 5. Now, as I mentioned earlier, the opposite of to the power of 5 is fifth root, okay? The opposite of square is square root. Opposite of cube is cube root. So what we're going to do is we're going to fifth root both sides. So if we fifth root the left-hand side, we're left with x. If we fifth root 32, we are left with 2. And let's just check if that makes sense. 2 times 2 times 2 times 2 times 2. That should give me 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That is correct. Okay, but obviously you can also use your calculator just to check yourself. I hope that that was helpful for you. I would like to do more videos like this. I actually do have more videos like this if you'd like to see them. Link down below. Let me know what other maths videos you'd like to see from me. Can't wait to see you in another video very soon, everyone. Bye.